the first inverse trig function we're talking about is inverse sine. And the way we write it is as follows. Sine negative 1x. So this means inverse. It's not 1 over, it's not reciprocal, it's inverse. So we have y equals sine inverse of x, sine inverse of x. That's the same as x equals the sine of y. Because here this x is a ratio and this y is an angle. So when I think about what I'm looking for, what I read this is I'm looking for the angle whose sine is x, or the ratio x. So let's think about the domain and range. For sine, my domain was negative infinity to infinity, everything worked. And my range was from negative 1 to 1. So remember, they would switch. So my input for my inverse sine would be negative 1 to 1. And if I was to pick a number outside of that domain, it would be invalid. Now you'd think that perhaps my range was negative infinity to infinity. But remember, the period of sine is 2 pi. That means it repeats every 2 pi. And if I think about my quadrants and the unit circle, remember that we talked about that the values are the same in each quadrant, it's just whether they're positive or negative. So I really only want a set of values for my angle that are positive and negative. And now if I look, I want to look at continuous. So if I look at 1 and 2, sine is positive in both of them, but in 1 and 4, it's negative and positive. So it turns out that my range is from negative pi over 2 to pi over 2. So when the output is going to be negative pi over 2 to pi over 2. Now sometimes we'll ask all values 0 to 2 pi, and then you have to figure out where the other one is. But if you use your calculator will only give you values between negative pi over 2 and pi over 2. And here all the values are negative, and here all the values are positive. Now let's also look, and we talked about that f of g of x has to equal x. So the same is true here. If I said, what is the sine of the sine inverse of x, that's going to be x. And if I ask what is the sine inverse of the sine of x, that also is going to be x. Now sometimes I have to be careful because of this range. So if I take the sine inverse of x, the value has to be somewhere in here. And then I will get the value back. But if I have the sine of x, and perhaps I give, my original x was 3 pi over 4. Well, the sine of x is radical 2 over 2, but if I do the inverse, it's going to give me pi over 4. So sometimes it's not x, but it's the reference value angle of x, but it still works every time.